Good afternoon. Today we'll talk about portfolio optimization and how to implement it. This is my table of contents for today. We're going to start off by the introduction. In this presentation, we'll talk about how to create an optimum portfolio with minimum risk and how to measure the expected return for portfolio under given conditions, and we'll also go through the investment strategy. Secondly, the methodology. And now I have to move to the Excel sheet to follow all the calculations that were made. Okay, in the first sheet is all the historical data collected for every stock for the period between the 10th of April and the 10th of May. Frankly speaking, the past month. We first calculate the monthly return. How to do this is by dividing the current price by the old price and subtracting it from 1. And then repeat the same step for each of the days to collect all the monthly returns. Moving on, now to calculate the monthly expected return, we'll use the average formula from the Excel to get the average of this set of numbers, all the monthly return, and then press enter. It will give us 0.07, for example, here, and then take this number, multiply it by 12 to get the yearly expected return. Then, for the standard deviation, which is representing the risk of the stock, we will use the standard deviation formula to the same set of numbers to get the monthly risk, then multiply the result of the monthly standard deviation by the square root of 12. This will give us the yearly standard deviation or risk of the stock. Now you have to repeat the same step, the previous steps for each and every stock of the stocks you've invested in to be able to achieve the yearly expected return and standard deviation of each and every stock. Now we move to the second spreadsheet, which is the portfolio sheet. Here we'll create a table consisting of the name of the assets, expected return, standard deviation or risk, minimum maximum weight, and the allocated weight. Start copying the data from the first sheet of the expected return and standard deviation of each and every stock. As for the minimum maximum weight, you can choose whatever. For instance, I chose 10% and 25%, which means that I don't want to invest in one stock more than 25% and no less than 10%. And as for the allocated weights, let's start with equal weights. Now, we'll calculate the expected return for the whole portfolio. And how to do that? It's by multiplying the expected return of each stock by its allocated weight. The summation of these multiplications will give us the expected return for the whole portfolio. As for the weight, it must be equal 100% or 1, which is the sum of the allocated weights column. Now, to calculate the standard deviation or risk of the portfolio, we'll need a covariance matrix, just like that one here. And to do that, we'll move to the third sheet, which is the covariance data. All you have to do is to collect the prices, the close prices of each and every stock for the period from 10th of May to, from the 10th of April till the 10th of May, in order to calculate the percentage of change. How to calculate that? It's by making a simple formula, which is the new price minus the old price divided by the old price. Repeat the same step for each and every stock, or simply drag from here to all the table in order to get the percentage of change in each and every stock you have. After having those results, you can go to the data, then pressing data analysis then pressing the covariance tab. Here you will highlight in the input range. First, you can click labels in first row in order to highlight the whole table. As for the input range, you'll highlight the whole table of the percentage of change and then press OK. By pressing OK, you'll get a covariance matrix just like this one here. Now we'll move to measure the standard deviation or risk of the portfolio by using a slightly difficult function from the Excel, which is square root of the multiplication, the transpose of the covariance matrix multiplied by the uh, the weights allocated to each and every stock here. By pressing enter, it will give you the exact risk coming out from the portfolio. And then the Sharpe ratio is simply calculated by, as you see here, it's calculated by a formula consisted of the expected return minus the risk-free rate divided by the standard deviation of risk or risk of the portfolio, and this will give you the Sharpe ratio of the whole portfolio. And now we'll move on to the part where we will choose the weights which I will invest in each stock. And how to do that, we'll use the Excel solver by going to data, then solver. The solver will open this tab. This tab will set an objective function. Here in this example, our objective function is minimizing the standard deviation or minimizing our risk. So let's click minimize, and clicking minimize, you'll choose this cell, which is the standard deviation cell. Our changing variables here are the weights, so we can just simply do this, changing these are our changing cells, and then setting some constraints. The constraints I set here, for instance, is that the first constraint is the total weight must always equal 1 or 100%, shown here. The second constraint is that all the weights for all the stocks must not exceed at 25%, which means that I don't want to invest in one stock more than 25% of the whole funds I will be investing with. And the third constraint is that I assign the minimum weight of 10%, that I don't want to invest in one stock less than 10%. And then we'll click simply solve. When clicking solve, the solver will assign specific weights to each stock in order to achieve the least standard deviation or risk possible. So here, just do this. So for instance, the standard deviation here is at 1.26%. The expected return is 2.59. The Sharpe ratio is a negative 9.33, and the solver said that this is the optimum solution to achieve a low standard deviation or a low risk portfolio from these stocks. Now back to our PowerPoint slides. After explaining all the formulas and stuff made in the Excel sheet and how we achieved the weights, calculated all the necessary the necessary results to get, like the standard deviation or the expected return for either the stocks or the portfolio, in order to get to make an optimum portfolio. Now we'll take a simple look on our stocks here, which were Fawri, Egyptian Resorts Company, Juhaina, Trufatla Hospitals, Talat Mustafa Group, CI Capital Holdings, Zaiza Steel, and Belton Financial. Those were the 8 stocks that were used in this portfolio. As for the conclusion, in this portfolio, our Sharpe ratio, the Sharpe ratio usually is used to help understand the return on an investment compared to its risk. In this portfolio specifically, the Sharpe ratio is a negative 9.33. It's weird to be negative, but the ratio here is a negative value, as the expected return of my portfolio is less than the risk-free rate, which was 14%, meaning that the given weights, uh, excuse me, the expected return in this portfolio was a 2.59%, meaning that the given weights that are required to minimize the risk is expected to return 2.59% for this portfolio. As for the risks, the risk of the portfolio, or the standard deviation, it was a 1.26%. This value normally indicates low risk, but in contrast with the expected return of this portfolio, it's considered normal, perhaps slightly risky, since since the return is below the risk-free rate. To sum up, I see, my opinion, the portfolio was doing good, except the part for the standard deviation, or that the expected return was below the risk-free rate for a short period of time, like the past month. So collecting data, I think the portfolio was an optimum portfolio for the given data. And that's all for today. Thank you for listening, and thank you for your time.